So in the question 2, we need to draw the non-zero definition region of fxy. So based on this question, we need to find the definition where x stays and y stays. So based on the definition, firstly we can get that y is bigger or equals to 1. So we draw the y equals to 1. That means the figure will be above this straight line. So after that, we also need to have this definition, which is the x is from the reciprocal of y to y. So in this figure, we can see that this straight line is y equals to x. So if we need to have x smaller than y, and y is bigger or equals to 1, so the curved area will be this one. So also we have the definition that x must be bigger than the reciprocal of y. So since this line is the y equals to the reciprocal of x, so if we need to have x larger than the reciprocal of y, it will on the right side of this line. So based on these two conditions, based on these three conditions, finally we can get that the non-zero definition of xy should be this curved area. So the second question is that we need to find a. So fxy is a valid joint density function. So if fxy is a valid joint density function, the double integration, the result of this double integration should be 1. So we need to calculate the fxy's double integration and finally calculate the result of a. So firstly, since a doesn't need to calculate in the integration, so we can extract it from the integration. And then first we can do the integration of x. So the integration of x is the integration from the reciprocal of y to y and the reciprocal of x dx. So after that we can get that the result of the integration of x is 2 times ln y. And after that we can also combine this result with the reciprocal of y squared, and finally we got this expression. So after that we need to calculate the result of integration y. So we suppose alpha equals to ln y and y equals to a power of e, alpha power of e. So after calculation we can get that the negative 2 divided a is 1, which means a is equals to 2. So in the second question, a equals to 2, so that fxy is a valid joint density function. So in the question 3, we need to find and draw the marginal density functions fx and fy. So based on the question 2, we just need to find a single integration of x and of y. So firstly, we can do the integration of x, and then we can get the marginal density function of y. So the fy equals to the integration from negative infinity to infinity fxy dx. So after calculation, we can get that the result of fy is ln y divide y squared, and y should be larger and equals to 1. Also, we can calculate fx by the integration from negative infinity to infinity fxy dy. So also we need to take two situations. The first one is that when x is bigger than 1, so the integration range is from x to infinity. So the result of fx is the reciprocal of 2 times x squared. And also we have another situation when x ranges from 0 to 1. So the integration of fx should be from the reciprocal of x to infinity, and the result of x will be the reciprocal of 2. So after that, we get both fx and fy, and then draw the figure of them. So finally, we should verify fx and fy are valid density functions. So if we need to verify whether fx or fy are density functions, we just need to have to examine whether their integration from negative infinity to infinity is 1. So after calculation, we can get that both fx and fy, the integration of them